I'm Nabil El Halya, and the presentation that I'm going to present is entitled Effect of Phosphorus Doping on Titanium Dioxide as Anode for High Performance Lithium Ion Batteries. So, rechargeable lithium-ion batteries have attracted attention as one of several promising electrochemical energy storage devices for electronic vehicles, for mobile phones, and also for renewable energy storage due to their high energy density, long cycle life, and zero emission. Titanium dioxide has garnered considerable interest among the new anode materials being considered for next generation lithium ion batteries due to some advantages such as fast lithium insertion at low voltage and low volume variation during the charge process. Titanium dioxide is also an expensive and environmentally friendly material. Generally, titanium dioxide exists in the phases of rutile, anatase, and brocade. The anatase phase can be considered a host material for electroactive lithium insertion. So a crucial disadvantage of anatase-tracted titanium dioxide is the low electric conductivity owing to its wide bandgap energy, so a significant hindrance in lithium-ion batteries and material, resulting in dramatic performance decreases at high rates in the charge-discharge process. So a doping technique is considered an efficient means of increasing the internal surface area and electrical conductivity. Doping with cationic or anionic dopants contributes to the formation of more open channel and active seats for lithium-ion ionospore via the expanding intraplanar spacing of titanium dioxide lattices. So in this work, we are interested on phosphorus doping using phosphoric acid as phosphorus precursor. So considering the experimental part, the p-doped titanium dioxide nanoparticles were synthesized via soil gel method. Typically, titanium tetraisopropoxide was used as titanium precursor, then sodium alginate polymer or biopolymer as complexing agent were used in the form of solution, and phosphoric acid was used as phosphorus precursor. So the crystal structures of the doped and non-doped titanium dioxide were identified by XRT as shown in this figure. So the diffraction peaks which are attributed to the diffraction plane of anatase titanium dioxide, indicating that the crystal faces of titanium dioxide remained after phosphorylation treatment. Also, the structural properties of the two materials were examined by Raman spectroscopy. So these obtained bands represent the Raman active mode of anatase phase of titanium dioxide, which are coincides and confirms the XRD results. For the absorbance measurements and compared to pure anatase, it's observed that the phosphorus doping extends the wavelength response range into the visible light region, and the band gap of titanium dioxide and p-doped titanium dioxide was 2.9 and 2.8 electron volt respectively. This results confirms the effect of phosphorus doping to reduce the band gap and improve the conductivity of titanium dioxide. Considering the electrochemical measurements, so the charge curves are illustrated in these figures for the doped and non-doped titanium dioxide, and as it can be seen here for both materials, for the charge curves has two plateau and 1.9 and 1.7 volt, representing cathodic and canonic peaks of anatase titanium dioxide nanoparticles respectively. Moreover, there is less polarization and less capacity loss for the p-doped electrodes, so these results will be attributed to the improved electronic conductivity. Cyclic voltammetry technique show also the presence of two cathodic anodic peaks at 1.7 and 1.9 volt respectively, which can be also attributed to insertion extraction of lithium ion in the titanium dioxide anatase nanoparticles. So these cathodic anodic peaks confirm the results obtained with the galvanostatic discharge profiles. So as a conclusion, the titanium oxide doped with phosphorus was sensitized by the soil gel method. Titanium oxide in the anatase phase has been sensitized successfully as confirmed by the various analysis technique. And finally, the doped titanium dioxide material present high electrochemical performance in comparison with the non-doped titanium dioxide. And thank you for your attention.